Go ahead.
Oh, you start.
I do? I do start, yes. Hello, I'm Dan.
And I'm Sarah, and we work at Lightning eMotors.
We're really proud of how far we've come since we started making electric vehicles back in 2017, and we'd like to show you what goes on inside. So please join us on a factory tour. Lightning eMotors is located in the former Hewlett-Packard campus in Loveland, Colorado, about 1 hour north of Denver and just 50 minutes drive from the Rocky Mountain National Park. Occupying around 230,000 square feet in 2 buildings, most of Lightning's employees are based here, including manufacturing, engineering, quality, marketing, and administration. Lightning encourages EV ownership and provides free charging to employees with EVs.
I'm standing in our Network Operations Center, which is the nervous system of our customer service department. They can see screens on the board here that show the different vehicles' health out in the field. So we can scroll through all of our vehicles in the field and select a random one to look at the vehicle's data and statistics. Down here on the left, you can see the route that the vehicle drove. Today it drove, looks like, downtown New York. And then on the right here is the different variables of the health metrics that we evaluate. Right now, they're all at 100%, which looks good. And then this chart here shows the state of charge of the vehicle dropping as it's driving. The real-time telematics data that every vehicle uploads whenever it's keyed on or charging isn't just used by our customer support team. Fleet managers can access it too on a subscription basis through our Lightning Insights portal. This allows the fleet manager to monitor all of the Lightning vehicles in their fleet with data on vehicle efficiency, state of charge, location, and other parameters. It's even possible to manage charging stations through this portal. Finally, this huge data set of real-world telematics is crucial for Lightning's engineers who can analyze it to understand how our vehicles are behaving on the roads in their daily duty cycles. This allows us to continually improve our products so they remain the most efficient and reliable in the industry. So I'm standing in our research and development area at Lightning eMotors. This is where our R&D team learns to electrify products that we've never electrified before. This is where they build our prototypes for our new products. And then once they've developed prototypes and they feel comfortable with the technology, then they do a formal technology transfer process where they document all of the work instructions and formally train our production team to launch products that are ready for full-scale manufacturing. I'm on our R&D floor and I'm standing next to our latest product, the Lightning Mobile DC Fast Charger. It's essentially a level 3 charger on wheels, so it can be used in a variety of applications where you need charging for EVs. This configuration specifically is 315 kilowatt hours with 4 outputs, so it's entirely battery powered and completely electric. This is our prototype unit, but it is now ready to go at full-scale manufacturing. So our R&D team is transferring the knowledge of how to build this product over to our production team. We're now on the production side of the factory. This is our fabrication area. So this is where we build the bracketry that holds different components, like our batteries, for example, into our EVs. We build a lot of it in-house, and it gives us a lot of flexibility as we're developing new products. This is our laser cutter machine. It produces hundreds of units every week by cutting sheet metal to very precise tolerances in different geometries for the bracketry in our vehicles. Our mechanical engineers design almost all of our metal parts to be cut from sheet steel or in some cases aluminum. This allows us to fabricate a wide variety of brackets and frames for almost any application in our vehicles. We don't just assume that the laser cutter is getting it right though. Our quality team operates an optical coordinate measuring machine to confirm that we're fabricating parts that meet our tolerance requirements. And speaking of quality, our entire quality management system is so comprehensive that we received ISO 9001 certification in August 2023. So all the units that come off the laser cutter are flat, but we need them bent to specific shapes for our EVs. So that's where the press brake comes in. This machine will bend sheet metal to very specific geometries and precise tolerances. This press brake is a CNC machine, which stands for Computer Numerical Control. Once the technician has dialed in all the settings for a new part, they save it to the machine and can recall those settings every time the part is being produced. So I'm standing in our weld shop. After parts go through the laser cutter and then the press brake, they come here to be welded into assemblies. After parts are welded, they need to be cleaned before they're powder coated. They go into the wash bay for a good rinse, and then they go to the oven to dry off. After that, they'll be put in the powder coating bay to get powder coated, and then they'll go back into the oven for curing. This is the finished product of our fabrication area. This will get quality audited before it gets to the next part of our process.
One of the things we have to get right is supply chain. Supply chain, of course, is the provision of the components, the parts and pieces that go together into assemblies and powertrains and eventually go into the vehicles that go out the door at the end of the process. Behind me, you'll see the controlled inventory cage. This contains a lot of the parts and pieces that we manage, and it's pretty much the case that nothing goes in or out of that cage without the ERP system knowing. We're now in the wiring area of the manufacturing floor. We make most of our wiring harnesses in-house because that gives us control over throughput, quality, and the ability to make changes as needed when the engineers come up with a variation on an existing harness. This makes us very light on our feet. For example, the R&D people often want a harness for a project they're working on. They can give the design to the wiring team, and very quickly a harness is made to their specifications and can allow the R&D team to continue work on their development. But most of the work here is for production, which means that we apply very high quality standards here, as well as doing what we can to improve the throughput while maintaining that quality. Building a wiring harness begins with a process called pulling, which is where the wires are actually put alongside each other in the right places from the right starting point to the right finishing point on a board such as the one you see behind me. This particular board is a little special because it uses a technology called LightGuide, which projects onto the board the instructions that the technician needs to follow. So for example, when it comes to pulling a wire, the projection will show first of all what kind and color of wire it needs to be, and then exactly where on the board that wire needs to be routed to make sure it goes into the right place in the final harness. It also shows things like where to apply the labels and which labels should be applied, because of course every wire needs to be labeled so that it ends up in the right place in the plug later on in the process. We find LightGuide is very beneficial because it helps the technicians get everything right first time, because it shows exactly on the board what they need to do. It's actually also more fun, and throughput goes up as well as quality. Once a wiring harness has been pulled, the next process is called pinning, which is where pins are applied to the ends of every single wire in the harness. This has to be done with extreme care and using equipment which is designed by the manufacturers of those pins to apply just the right amount of crimping force so that those joins are reliable and will work in a vehicle for many years. After all those pins have been installed, the harness goes to plugging, which is where all the connectors are attached. Each harness may have multiple connectors and, indeed, multiple types of connectors. Once a harness has been pulled, pinned and plugged, it needs to be tested to make sure that it's been built correctly. That's done here at the test station. We have a library of test fixtures for every production harness. All of the plugs on the harness are connected to the corresponding receptacles on the fixture. The fixture is connected to the test computer and the test sequence is run. This tells us if the harness was built correctly or if there are any mistakes that need to be fixed. Harnesses which have passed testing are then loomed, which means one of two things. Either they are wrapped in an adhesive cloth tape, which we use for low voltage harnesses which are inside the vehicle, or they're encased in a flexible plastic cladding called split loom. This is used for all high voltage cables and any low voltage cables which are exposed to the elements under the vehicle. Our electric powertrains have multiple thermal systems, providing heating or cooling as needed. One example is thermal management of the battery packs, which need to be kept at their ideal operating temperature, so we automatically heat them up on cold days or cool them down on hot days. Most of these systems use 50-50 coolant, just like in a gasoline car, but at lower pressures. So I'm now standing in the powertrain assembly area of our production floor. By powertrain, I mean everything that goes into a vehicle to make it an electric vehicle, except perhaps the batteries. They get put in the vehicle later on during the vehicle assembly process. But the powertrain, such as this collection of components that you see next to me, is something that's assembled right here on the factory floor. This is a powertrain for one of our ZEV4 Class 4 vehicles based on the GM 4500 chassis. This assembly carries the high voltage power distribution, as well as pumps and heaters related to the thermal systems, the air conditioning compressor, and the main controller which runs our software. The electric motor is in a cradle of its own, which is mounted not far in front of the rear axle. The impressive brake assembly you can see there is not used for slowing the vehicle, it's actually a redundant e-brake for additional safety. The two grey boxes in this assembly take care of AC charging by converting AC electricity into the DC power that the batteries need when charging. And this assembly carries the power inverter, which sends three-phase AC electricity to the motor.
So once a powertrain comes off our powertrain production line, it gets a full visual and tactile inspection and then comes over here to the pre-commissioning area. This is where all the controllers get their software, all the harnesses are tested for continuity, and it gets mated with its batteries that'll go into the vehicle. Everything is tested that can be tested outside of the vehicle.
This is the vehicle assembly area of the Lightning eMotors factory. This is where everything that you've seen so far in this tour comes together and the magic happens. This is where vehicles become fully electric and go out of the door, impacting the environment and impacting the sustainability goals of the fleets and customers that buy them. Every vehicle that comes into the factory already has a gasoline engine. Of course, we would prefer to get what are called gliders, which are vehicles which never had an engine installed, and we expect to get them in the future. For now, however, we need to remove the fluids, the engine, transmission, fuel system and exhaust system in a process we call decontenting. We're often asked what happens to the engines. The answer is we sell them to a guy who buys them from us every few weeks.
After decontenting, vehicles are placed in assembly stations for the various operations which convert them into electric vehicles. Powertrain assemblies get installed under the hood and in various locations in the chassis. For example, on the ZEV4 platform, the electric motor is installed quite close to the rear axle. This allows us to place battery packs further forward because there's no drive shaft ahead of the motor. Battery packs are raised up to the vehicle using compressed air lifts, which allow precise positioning so the technicians can easily and safely install the bolts which hold them in place. There's a lot of work that goes on in the cab too, as we replace the existing instrument cluster with our own digital dashboard. We also install the electronic gear selection buttons here. When the conversion is complete, the vehicle goes to the commissioning area. A full visual inspection is conducted to confirm the vehicle is manufactured to our high quality standards. Technicians now key on the vehicle for the first time and ensure each system is working properly. High voltage systems are a critical part of the testing, as well as low voltage and HVAC systems. Everything is tested, such as the headlamps, pumps, and temperature sensors. The vehicle is charged on both level 2 and level 3 chargers, and then it is driven for at least 50 miles to complete the commissioning process. Once our vehicles are fully built, commissioned, and quality audited, they will leave the factory and be on their way to the customers. This school bus will join over 600 Lightning vehicles already on the roads of North America, which have covered 5 million emission-free miles and counting. Well, we hope you enjoyed that tour.
We hope it was informative and you learned what goes on behind these walls. And if you want to learn more, go to lightningemotors.com. Bye now.